Hi, my name is Dan Humes, and in this video, I'm going to walk you through the complete analysis for repeated measures ANOVA, examining how attitude change over time after eating chocolate. I'll cover the research question, the hypotenuse, how the analysis was set up in SPSS, assumption checks, ANOVA results, the pairwise comparison, effect size, and whether the changes we observed were actually meaningful in a real world sense. And by the end, we'll have a clear picture of how statistically our findings are and what they imply. The focus of this study focuses on a simple but interesting question. Does attitude over time after someone eats chocolate change? To answer that question, we measured attitude assessment scores at 4 different time points: before eating chocolate, 5 minutes after eating chocolate, 1 hour after eating chocolate, and 4 hours after eating chocolate. From this, we set up 2 hypotheses. The null hypothesis states that time has no effect on attitude. In other words, the mean scores for all 4 points are equal. And the alternative hypothesis predicts that at least one of the 3 means is different, suggesting that attitudes do change over time. These hypotenuses guide the entire analysis. To run the repeated ANOVA, we first open the SPSS software and we drop in our data set, chocolate and attitude over time .sav file, into the workspace. This confirms that we have the 4 AAS scores: 3, 5 minute, 1 hour, 4 hour. To run this test, we go up and we hit Analyze. We pull down to General Linear Model, hit Repeated Measures, and we type in time into the factor. We type in 4 time slots. We hit Add. This tells us we already have one there. All right, fine. Then we go to Define. Now, when we first open up, they'll be over here on the left-hand side, and you'll just have 1, 2, 3, 4 with a question mark. You click on these and drag them into the Within Subject Variable window. Then we'll go to Plots, and we want a plot, specifically this one here. It'll be a line chart, and it will show us where our means are going to be. Then we'll hit Models, Display Means for Time, Compare Mean Effect, Continue. We'll hit Options. These are the tests we want to display: descriptive stats, estimates of effect time, observed power, homogeneous test. Make sure that our significant level is 0.05. Click OK. Hit OK. Now it will bring up all the tables that we need for these tests. It will give us everything we need to answer questions. We want to ask, we're checking to see that we have Marchley spontaneously before interpreting the ANOVA results. This, unlike some of our other tests, isn't automatically assumed, it must be tested. The results displayed in the row of ANOVA tables will allow us to use the test evaluations to see whether the variances of the difference between time points are equal. And our output for the Marchley W was .860 with a p-value of 0.683. Because p-value is greater than 0.05, the assumption of sphericity was not violated. That means we use the sphericity assumed row in our test. This is important because using the wrong row could lead to incorrect degrees of freedom and potentially incorrect conclusions. Within the assumptions, we move to the main ANOVA test, and the significance sphericity assumed row showed significant effective time on attitudes. F is equal to parenthesis 3,66 close parenthesis equals 5.681. P is 0.02 with a partial eta square of 0.205. The two things this tells us is, first, the p-value is well below 0.05, so we reject the null hypothesis, conclude that attitudes do change over time. The second, the effect size, which is 0.205, falls in the moderate to large range. That means the change isn't just detectable, but represents a meaningful shift in data. So the ANOVA gives us a clear signal. Time does matter in this study. Now, the next step is to check and figure out where the differences occur. Well, that's pretty easy to see if you look at the graph, the plot. We see that these scores are fairly close, but the one that's really, the means are really high is on the 5-minute, which tells us that 5 minutes, approximately 5 minutes after eating chocolate, we see a large attitude change. Then down to about an hour, it settles. And then from there to 4 hours, it stays pretty much the same. Attitudes at 5 minutes were significantly higher than at pre. Attitudes at 5 minutes were also significantly higher than 1 hour or 4 hour. And this plot reinforces that, as long as looking at the tables does too. So our effect is statistically significant. The effect .205, of course, as I said, has a moderate to large impact. So people do show a noticeable improvement in attitude just a few minutes after eating. And this aligns with real-world experiences, where that small emotional lift you get from eating something sweet. But the key point is how quickly this fades. At 4 hours, it's completely gone. So while it is real and measurable, it's also fleeting. In practical terms, the results suggest that chocolate can brighten someone's mood, but only for a short window. The final conclusion is the repeated ANOVA showed a significant effect of time on attitude scores, driven entirely by short-term increases at the 5-minute mark. The effect size indicates that this change is meaningful, but its direction is limited. It gives us a boost in attitude, but not a long-term boost. So I'd like to thank you for watching.